السلام عليكم ورحمة الله وبركاته. أرحب أنا آلاء السيف بالحضور الكرام نيابة عن المركز الوطني للتعليم الإلكتروني من العاصمة الرياض بالمملكة العربية السعودية. هذه الندوة الافتراضية بالتعاون مع الهيئة السعودية للبيانات والذكاء الاصطناعي سدايا، وجامعة الملك عبد الله للعلوم والتقنية، والكلية التقنية العالمية لعلوم الطيران بالرياض، تحت عنوان التعليم الرقمي باستخدام الذكاء الاصطناعي، حلول مبتكرة لتعزيز تجربة التعلم. في هذه الندوة نستعرض بحول الله التأثير التحويلي للذكاء الاصطناعي في مجالي التعليم والتعلم الرقمي، ونركز أيضاً على التطبيقات المبتكرة التي تساهم في تعزيز نتائج التعلم، كما سنسلط الضوء على دور الذكاء الاصطناعي في دعم التعلم التكيفي وتقديم الحلول العملية التي تساعد المعلمين والمعلمات في تحسين التجربة التعليمية لهم ولطلابهم. بالإضافة إلى ذلك ستتناول هذه الدورة الأبعاد الأخلاقية والمخاوف المرتبطة باستخدامات الذكاء الاصطناعي في التعليم. ستوفر أيضاً رؤية شاملة حول إمكانيات هذه التكنولوجيا في إحداث ثورة تعليمية في العصر الرقمي. بداية أحب أن أنوه إلى أن هذه الندوة ستقدم باللغة الإنجليزية، لكن ستكون ترجمة فورية للغة العربية ولغات الإشارة متاحة خلال هذه الندوة. بإمكانكم الضغط على أيقونة الترجمة، تجدونها في علامة الكرة الأرضية أسفل الشاشة. بالإضافة إلى أنه سيكون هناك استبيان قصير في نهاية الندوة، يمكنكم تعبئة الاستبيان بهدف تحسين والتطوير. Greetings from the National E-Learning Center in the city Riyadh, the capital of Saudi Arabia. We are delighted to welcome each participant in today's webinar on digital learning using innovation solutions to enhance the learning experience in collaboration with the Saudi Data and Artificial Intelligence Authority, SDAIA, and King Abdullah University of Science and Technology, and the International Aviation Technical College at Riyadh. The aim of this webinar is to explore the transformative impact of artificial intelligence in the field of education in this digital era. And we are focusing on innovative applications that enhances the learning outcomes. This webinar will be highlighting the role of AI, artificial intelligence, in supporting adaptive learning and providing practical solutions to help educators improve their educational experiences. Additionally, this webinar will be also addressing the ethics of AI, the concerns around it, especially in education, offering a comprehensive view of the potential of the technological era, let's say, in education and its impact in education as well. So, welcome again. I'm your host, Ala As-Saif. I'm a digital education and capability building expert at SDAIA. I would also like to introduce our panelists here. Please welcome Dr. Najla Atwajri. She is the General Manager of Public Education Sector at SDAIA. Dr. Najla has over 25 years of experience in education. She is focusing on empowering students through science. Dr. Najla initiated the first Saudi National Olympiad in Artificial Intelligence at the Center of Excellence for AI in Education. She is developing AI use cases actually in education in-house at the Center of Education, Center of Artificial Intelligence, especially the Department of Education, including a smart learning management system and an AI-powered tutor. We are also delighted to welcome Professor George Reka. He is a research professor in applied mathematics and computational science at KAUST. We are also delighted to have with us Engineer Mohammed Janani, Instructional Design and AI Integration Manager at IATC. We thank those speakers for joining us today. We're going to start our webinar actually with Dr. Najla, and she will be guiding us today through the transformative power of artificial intelligence in education, exploring both its innovative applications and the critical ethical aspects of AI. As we cover those range of topics, we will also include analytics of AI in education, augmented reality, and also automated grading that can help teachers reduce the time spent in class on those kind of tasks and focus on more interactive ways to interact with students, as well as the feedbacks mechanisms that AI now can offer. So if you please join us, Dr. Najla, with your presentation.
Thank you very much, Dr. Ala. Can you see my screen now?
Yes, we can.
Okay, so good afternoon again, everybody, and thank you very much for being here today. My name is Najla Tuwajri, and I'm really excited to share with you some insights into a topic that is becoming increasingly important in the field of education, and that's the role of artificial intelligence or AI in education. So the title of my presentation is AI in Education, Use Cases and Ethical Implications. And over the next 15 to 20 minutes, we'll be exploring how AI is currently being used to enhance educational practices and what this means for students, educators, and the educational system as a whole. We will also explore the ethical concerns that arise with the growing use of AI in education. While AI has the potential to greatly benefit the educational process, it also comes with significant responsibilities. We will discuss issues such as bias, data privacy, accountability, and ensuring equitable access to AI-driven educational tools. I hope that by the end of this presentation, you'll have a clearer understanding of both the opportunities and the challenges that AI brings to education, and why it's so important to approach this technology with both enthusiasm as well as caution. So let's get started. First of all, we'd like to define what is AI in education. Now, artificial intelligence has increasingly become a vital component of modern education. When we talk about AI in education, we're referring to the use of intelligent systems and algorithms to enhance and optimize various educational processes. This can range from personalized learning platforms that adapt to individual student needs, to AI-powered tools that assist teachers in grading and providing feedback. I'd like to give you some historical context on AI applications in education. So AI's journey in education began with some relatively simple tools, things like language translation tools and basic tutoring systems. Over the years, however, these applications have evolved, and today AI is capable of performing complex tasks, such as analyzing large data sets to predict student outcomes, or creating adaptive learning paths, and even offering personalized tutoring sessions. The importance of AI in education cannot be overstated. As classrooms become more diverse, with students having varying needs, backgrounds, and learning styles, the traditional one-size-fits-all approach to education is no longer sufficient. AI enables us to move towards a more personalized, flexible, and inclusive educational system. It can help educators meet students where they are, providing the right support at the right time. Additionally, AI can automate administrative tasks, allowing teachers to focus more on the aspects of teaching that require a human touch, like mentoring or providing emotional support, for example. So AI in education is not just a trend, it's a fundamental shift in how education is delivered and managed. And as we move forward, understanding AI's role and its potential impact is crucial for educators, students, and policymakers alike. So throughout this presentation, we will explore both the exciting opportunities and the critical challenges that AI brings to the educational landscape. As I said, I'm going to give you some use cases. This is the first one, so personalized learning. This is one of the most significant and transformative applications of AI in education. It's an educational approach where the content, the pace, and the learning style are all tailored to each student's individual needs. This contrasts, as I said before, with the traditional method where all students typically receive the same instruction at the same pace, regardless of their unique abilities or their learning preferences. AI plays a crucial role in making personalized learning a reality. Through the use of AI-driven tools, educational platforms can continuously analyze data about a student's performance, behavior, and preferences. Then the systems can use this data to adapt the learning experience in real time. For example, if a student is struggling with a particular maths concept, AI can recognize this and provide additional resources, exercises, or even adjust the difficulty level to help the student master the topic before moving on to another one. There are platforms like, for example, Dreambox for maths or Newton for various subjects, and these all use adaptive learning technology to create customized learning paths for students. And as students work through the material, the AI will track their progress. It will identify areas where they need more practice, and it will adjust the content accordingly. Another example is Coursera, which uses AI to recommend courses or specific modules to learners based on their previous activity and learning goals. The benefits of personalized learning extend to both the students and the educators. For students, personalized learning can lead to greater engagement, greater motivation, because the learning experience feels more relevant to the student, more responsive to their needs. It can also help bridge gaps in understanding by providing targeted support exactly where it's needed, leading to better academic outcomes. For educators, personalized learning powered by AI offers a very valuable tool because it can manage diverse classrooms. Teachers can use these insights to provide more focused and effective instruction, allowing the educators to spend more time supporting students who may need some extra help. Now, sorry. For our second use case, we will speak about AI tutors and assistants. This is another powerful application of AI in education. These are AI-driven tools which are designed to provide students with personalized support and help educators manage their workload more efficiently. AI tutors are systems that mimic the role of a human tutor by providing personalized guidance and feedback to students. Unlike traditional tutoring, which may be limited by time and availability, AI tutors are available 24/7. This means students can receive help whenever they need it, whether it's late at night, before an exam, during homework sessions at home. One of the most well-known examples is IBM's Watson Tutor. Watson can engage in a dialogue with students. It can ask probing questions. It can provide detailed explanations on various topics. It can also help reinforce learning in a more interactive way. Similarly, AI-powered virtual assistants are becoming increasingly common in educational settings. These tools handle a wide range of administrative tools, such as answering frequently asked questions, or providing reminders about deadlines, or even helping students navigate course materials. Chatbots are being used in universities at the moment to assist students with course registration, answering queries about campus facilities, or providing guidance on assignments. The role of these AI tutors and assistants is crucial in today's educational landscape. They provide students with continuous support. If a student is struggling, for example, with a concept or has a question outside of classroom hours, this is especially beneficial in online or hybrid learning environments where students may not have immediate access to their teachers. Even for educators, these tools significantly reduce the administrative burden. AI assistants can take on tasks such as grading simple assignments, organizing course materials, managing student inquiries, and this will free up time for the educators to focus on more complex aspects of instruction and student interaction. But it's important to note that while these tutors and assistants are incredibly useful, they are not a replacement for human educators. The value they provide is supplementing traditional teaching methods, offering additional support, enhancing the overall learning experience. But as I said, they are not a replacement for human educators. Another use case that we can speak about is predictive analytics in education. Predictive analytics refers to the process of using historical data, statistical algorithms, and machine learning techniques to make predictions about future outcomes. So in the context of education, predictive analytics can provide incredibly valuable insights that help improve student outcomes and optimize their experience. One of the most impactful ways that predictive analysis is being used is in identifying students who are at risk. So by analyzing various data points, such as attendance records, grades, engagement in class activities, and even social factors, AI systems can identify patterns that may indicate where a student is at risk of failing or dropping out. For example, let's suppose that there's a student whose engagement in an online course suddenly decreases or their grades begin to slip. Predictive models can flag this and alert the educator to intervene early enough. This early warning would enable the school, enable the university to provide targeted support for this student in particular, whether that be through additional tutoring, counseling, or any other kind of intervention. Predictive analysis also plays a key role in optimizing resource allocation within educational institutions. For example, by analyzing enrollment trends and student performance, schools can make informed decisions about whether to allocate resources such as staffing, classroom space, educational materials. This would ensure that resources are directed where they are most needed, improving overall efficiency and effectiveness. Another important application is in curriculum development. So predictive analytics can help educators understand where areas of the curriculum may need adjustment based on student performance and their engagement data. For example, if a significant number of students are struggling with a particular concept, predictive analytics can identify this trend, promoting a review of how the material is being taught. These data-driven insights extend beyond individual classrooms, because at a broader level, educational institutions can use predictive analytics to inform policy decisions, improve student retention rates, enhance overall academic performance. The ability to make informed, proactive decisions based on real-time data is a powerful tool that can lead to better outcomes for both students and educators. However, while predictive analytics offers many benefits, it is really important to handle student data with care. Privacy concerns must be addressed, and the use of predictive models should always be transparent and ethically sound. We will speak about this later on. Another use case is automated grading and feedback. Now, as class sizes grow and educators are required to manage an increasing number of assignments and assessments, the ability of AI to streamline the grading process has become honestly invaluable. Automated grading systems use AI algorithms to assess student work quickly and accurately. These systems are particularly effective for grading objective types of assessments, such as multiple choice questions, true or false questions. However, advancements in AI have also made it possible to grade complex assignments, such as essays or short answer questions. For instance, AI can evaluate the structure, the grammar, the content, relevancy of an essay, and provide a score almost instantaneously. One example of this is the AI-powered systems used in standardized testing environments, where essays are scored by AI to provide quick and consistent results. Similarly, in massive open online courses, MOOCs, AI systems are used to grade thousands of student submissions, providing immediate feedback for these students. This would help them improve without having to wait for days or weeks for a human grader to review their work. So the benefits of automated grading are clear. First, it significantly reduces the workload for educators, freeing up their time to focus on other important tasks such as lesson planning, one-to-one student interactions, or their own professional development. This is especially valuable in large classes or online courses where the volume of assignments can be overwhelming. Second, automated grading can enhance the learning experience for students by providing instant feedback. And so instead of waiting for their assignments to be returned, students can quickly see where they did well and where they need to improve. This would allow them to make immediate adjustments to their learning strategies. However, while automated grading offers these advantages, it's important to acknowledge the potential downsides. One of the main concerns is the risk of bias in AI grading. If an AI system has been trained on a biased data set, it may produce biased results, unfairly favoring certain writing styles, for example. Additionally, AI systems may struggle with nuances in student responses, such as students who have given a creative answer or an unconventional approach. A human grader would appreciate these, but an AI system might overlook these if it is not trained on these kinds of answers. So in order to mitigate these risks, it's really essential to ensure that automated grading systems have regular testing and are updated to reduce bias and improve accuracy. Moreover, human oversight should always be part of the grading process, especially for assignments that require some sort of subjective evaluations. While speaking about these use cases, we did speak a little bit about the ethical implications. So I'd like to give first an overview, but what I mean by this. So while AI offers many opportunities to enhance learning and teaching, it also introduces challenges that must be carefully managed to ensure that the use of AI in education is both fair and responsible. So the integration of AI into education raises several key ethical concerns, and addressing these concerns is really essential. The first area we need to focus on, as I said, bias in AI algorithms. AI systems are only as good as the data that they are trained on. So if the data contains biases, these biases will be reflected on the AI's decisions, leading to unfair outcomes for certain groups of students. Another critical concern is students' privacy and data security. AI systems in education often require access to vast amounts of student data to function effectively. This data can include sensitive information such as academic records, students' behavioral data, even personal identifiers. So ensuring that this data is protected and used responsibly is actually quite important. Another major issue is accountability. And as AI systems take on more roles in education, including grading, making predictions about student performance, and even influencing some important decisions, it's crucial to establish clear accountability. Who is responsible when an AI system makes a mistake? How do we ensure that the AI decisions are transparent and can be understood by educators and students alike? We must also consider the issues of equity and access. As AI tools become more integrated into educational systems, there is a risk that these technologies would make existing inequalities, even worse. Students from lower socioeconomic backgrounds or those without access to the necessary technology could be left behind, widening the digital divide that we have. So I'm going to address a number of ethical concerns, which I gave an overview about just now. The first one is biases in AI algorithms. So this is one of the most significant ethical concerns. As I said, bias in AI occurs when the algorithm produces results that unfairly favor certain groups over others. And this can happen when the data used to train these algorithms reflects existing biases, whether they may be cultural, racial, gender-based. In the context of education, bias in AI can have serious implications. For example, let's consider an AI system which is used for grading or assessing student performance. If the training data for these systems include a certain bias, perhaps favoring a certain language style, for example, penalizing non-native speakers, then the AI might consistently give lower scores to students from certain backgrounds. This can result in unfair academic outcomes, reinforcing existing inequalities rather than helping to overcome them. Another example is in predictive analytics, where AI might be used to identify students at risk of dropping out or underperforming. If the AI model has been trained on data that disproportionately flags students from particular demographics as high-risk students, it can lead to unjust interventions, and these students might be singled out or given some support that they don't actually need, based purely just on the AI system's prediction. So mitigating bias in AI requires a multifaceted approach. First, we need to ensure that the data used to train AI models is as diverse and representative as possible. This means including data from a wide range of demographics, learning styles, and cultural contexts. It also means that we need to update the data on a regular basis so that the models would reflect changes in society or in the educational environment. Secondly, transparency is key. Educators and developers need to understand how these AI systems make decisions. This involves opening up what's called the black box of AI. So making the decision-making process of AI systems more explainable. When educators understand how an AI system reaches a conclusion, they can better identify potential biases and intervene when necessary. Finally, it's crucial to involve human oversight in AI decision-making processes, because while AI can handle these large data sets and complex patterns, it can never replace human judgment, especially in areas where nuanced understanding is required. Educators should have the final say, using AI as a tool to support their decisions and not as a replacement to their expertise. Another ethical concern is, as I said before, student privacy and data security. When AI systems become more integrated into educational environments, they often require access to large amounts of student data, which can include sensitive information, such as I mentioned before, things like academic records, attendance, health information, personal identifiers. And this data is essential for AI to function efficiently, but it also raises significant concerns about how it is collected, how it is stored, and how it is used. The first major concern is data privacy. Students, parents, educators need to be confident that the information being collected is handled with the utmost care and used solely for the intended educational purposes. There have been cases where this data was misused for commercial purposes, for example. So such breaches as these can have serious consequences, such as identity theft and loss of trust in the educational institution. Another concern is data security. Educational institutions are increasingly becoming targets for cyber attacks, with student data being a valuable target. A data breach in a school or university could expose sensitive information of thousands of students, leading to severe implications for their privacy and security. This is why robust security measures are essential to protect this data from unauthorized access and breaches. Now, to address these concerns, it's crucial to implement strong data protection policies and practices. First and foremost, educational institutions must ensure that data is collected with clear consent from students or from their guardians, with full transparency about how it will be used and who will have access to it. This includes informing them about their rights to access, correct, or delete their data. Secondly, robust security protocols must be in place. This means using encryption to protect the data in both transit and at rest, ensuring that only authorized personnel have access to sensitive information, and regularly updating security measurements to defend against new threats. Additionally, institutions should conduct regular audits and assessments of their data security practices to identify and address any vulnerabilities, any points where somebody can access this data. And I suppose finally, if we foster a culture of privacy and security awareness among the educators, students, and staff, this is quite essential, because this includes training them on the best practices of how to deal with the data. Okay, I'll go to the next one then. I'd like to speak here about the ethical concerns of accountability in AI decision making. So one of the main challenges with AI is, as I said before, the so-called black box problem. Many AI systems operate in ways that are not easily understandable, even by their developers. And so this lack of transparency can make it difficult to understand how a particular decision was made, such as why a student received a certain grade, or why another was flagged as being at risk or failing. So when decisions are made by these AI systems, those decisions are not transparent, it becomes challenging to hold anyone accountable if something goes wrong. To address these concerns, it's crucial to establish clear accountability frameworks when using AI in education. First, AI systems should be designed with transparency in mind. This means that the decision-making process of all AI systems it should be as understandable as possible. Educators, administrators should have access to explanations of how an AI system arrived at a certain conclusion. This would allow them to review and challenge decisions when necessary. Additionally, there should be clear guidelines on who is responsible for these decisions. If an AI system makes a mistake, such as grading students unfairly, there must be a clear process for addressing these errors and determining who is accountable. This could involve the AI developers, the educational institution that implemented the system, or the educators using it. Finally, there should be mechanisms in place for students and educators to report issues with the AI systems and to have these concerns addressed in a timely manner. This could include formal processes for appealing AI decisions, where such as how students can currently appeal grades given by human teachers. Finally, the final ethical concern is equity and accessibility. One of the primary concerns is the digital divide, the gap between those who have easy access to modern information and communication technology and those who do not. If AI-driven tools do become the norm, students who do not have access to these technologies could be left behind. This would widen the gap between them and their peers. And even when students do have access to AI tools, we can, for instance, have an AI-powered personalized learning platform, which is more readily available in well-funded schools, for example. That would provide students with more tailored education. Another aspect of equity is ensuring that AI systems themselves don't have biases. For example, if AI tools are trained on data that reflects some certain biases, for example. To address all of these equity concerns, we need to have several important steps. So we must work to close the digital divide by ensuring that all students have access to the necessary technology. We should advocate for equitable access to AI-driven educational tools, and it's essential to involve diverse voices in the development and deployment of AI systems in education. I think that I will stop here because I think I've gone over the time allocated for me. I would like to thank you all. I would like to thank you all for your time. And if you have any further questions or would like to discuss any of the points that I covered today in more detail, please don't hesitate to reach out. And thank you very much again.
Thank you so much, Dr. Najla, for providing this valuable insights on balancing technological advancement with the ethical responsibilities. Dr. Najla, if you please would like to ask you a question, since we have a great amount of teachers joining us today in this webinar. How advanced is the Arabic AI-powered applications today? And if so, can you recommend some names that teachers can be using in today's classroom? Thank you.
Well, there are a number of AI applications which use the Arabic language. As you know, here at the National Center for Artificial Intelligence, we have developed our own Arabic LLM, Allam, which was launched a couple of months ago. My colleague, Professor George, will be speaking about an learning management system that is in Arabic, that is tailored for the Saudi curriculum, and that actually uses Allam for personalized learning for students, as well as for teachers alike.
Thank you, Dr. Najla. And you have examined the ethical landscape, addressing some key concerns such as bias in AI algorithms, students' privacy and data security, accountability on actually the AI decision making, and issues around equity of access. My question to you, Dr. Najla, is how how can we determine who is the person or let's say group of people responsible for this role? Like, I mean, regulation, legislation on the ethical of artificial intelligence in education. Is it the government bodies or the educational institution, or is it what's your thought around this?
Well, as I mentioned, there should be clear guidelines when a system is implemented upon who is responsible for the decisions and who is accountable. So these guidelines should be in place before a system is in place, because if the guidelines state that the institution using it is responsible for the decisions, then it would be the institution. If it's the developers, then the developer. If it's the teacher or let's say the educator, whether would be responsible, then these things, again, should be guidelines which are clear to an institution, to teachers, to parents, to students before a system is used.
Thank you so much, Dr. Najla Tuwajri. And now please join me in welcoming Professor George Turkiya, Research Professor in Applied Mathematics and Computational Science at KAUST. He is going to guide us through the role of AI enhancing the adaptive learning. Please join us, Dr. George.
All right. Thank you. Thank you for the introduction. And I hope you can see my slides here.
Yes, we can see it.
All right. So, and thank you, Dr. Najla, for the presentation. It's a wonderful segue into what I'm about to share here with you. Let me just... so what I'd like to do is actually share with you some vignettes from a system we're currently developing. Actually, we're developing, it's under active development for AI tutoring, AI-based tutoring, and for a personalized math learning system. So we've been developing together at the sort of Sadaya KAUST AI Research Center a system for a math tutoring, an AI-based system for math tutoring to help students in this. So what I'd like to talk about is sort of some of the components of the system and how they work together, and what we're hoping to achieve when the system is fully fleshed out and deployed. So I'll talk a little bit about sort of how we organize the knowledge in the system, and this idea of knowledge components. These are the fine-grained pieces of information that we use that everything hangs from. And I want to talk a little bit about how we generate student assessment, the multiple choice questions, and how we relate them to these knowledge components to assess what students know. And I'd like to also share with you a little bit about sort of the conversational style tutoring system, how a tutoring system can work in context when a student is trying to solve a problem, how they can help them. And these actually, as you will see in some of the screenshots I'll share with you, they are done in Arabic using the Saudi curriculum. So these are very much customized to the needs of the current, grade 12 people in the kingdom. And then in the end, I'll finish by showing how we represent sort of the student model, what the student knows, and how we can use that data to provide the basis for sort of analytics and getting insights about performance. So knowledge components, these really are sort of the very fine-grained competencies that an adaptive learning platform seeks to deliver. So these are sort of at a much finer granularity than sort of broad learning objectives and goals and stuff like that. These are the little fine units of information. So the word in the field has been called knowledge components. These are the particular competencies that we can test for, that we can grade on, and these actually are extracted from a curriculum. So these are the kinds of things that we would like a student to know to pass something. So, and being able to handle these sort of fine-grained competencies is critical if we want to enable adaptive content so that we can sequence the information to the students, if we want to drive analytics, if we want to estimate what the student knows, how we can guide them further. We do need this sort of very detailed information about what they know. So what we've done in this project is actually we took the grade 12 math curriculum that is used in the kingdom. I think many people perhaps are familiar with this sort of textbooks. And we extracted the knowledge from that textbook, partly so that people, so that our tutoring system and our assessment systems are familiar to the students who will use them. So this is, for example, the grade 12 math curriculum. These are so this is the curriculum for the whole year. These are the individual topics that students are expected to know. One of these topics is sort of this tahleel al-dawal, this analysis of functions. And you can see here in the middle plot. So this is further subdivided into these concepts, these green little dots here. This is sort of what this topic, this analysis functions. We need to do a bunch of things. We need to analyze limits here, what this dot is, do inverse functions, the various things that the kind of concepts a student needs to master in order to be able to sort of analyze the behavior of functions properly. Unfortunately, these concepts are still too coarse for an AI learning system to really be able to deliver that material in a targeted, in a precise way. So we go down further. So this is, what this concept is, analysis of functions. This is, sort of the mega concept, if you will, a topic. In a topic, we're going to talk about الاتصال والنهايات, continuity and limits and these kinds of things. This is still too coarse, so we go further, and this is sort of what the knowledge component is, something reasonably fine-grained. So this is, for example, نظرية القيمة المتوسطة. This is the mean value theorem, the famous theorem that people want. And then individually, the particular things we're going to assess, can students sort of figure out when does the function change sign, when does it go through the zero, when does it go to infinity, these kinds of things. So the idea is to take the knowledge from a textbook and put it in this form that then an AI system can start to use in order to question students and in those particular knowledge components. So for example, here, we generated these multiple choice questions that are linked to a particular knowledge component. For example, this is إيجاد قيم الدالة. This is just, function evaluation. Can we evaluate functions and make inferences from that? So we have multiple choice questions, MCQs, that are tagged with the knowledge components. These are, of course, going to be organized in difficulty order. And what is interesting is the distractors. So the way these multiple choice questions are generated automatically, of course, and we generated distractors. Distractors are the incorrect answers in the multiple choice. So these are generated automatically using, I'll show you the next slide, how we generate them automatically. So we have this question. The question either could come from a textbook or it can be generated by a language model. But the distractors, so these are the kinds of choices given to a student. These are generated automatically. And we do so by sort of simulating a faulty reasoning sequence of steps. So, for example, this is a question here where we want to figure out whether the student can understand what is the limit behavior of this polynomial function. And we're given different choices, and what we are hoping to do is, so the student is going to pick one of these choices, and this is actually a slide to just describe how our distractors, our incorrect choices were generated. So these are the kinds of data sources here. I'm talking right now about the math textbook, the Saudi curriculum math textbook. So what we actually do is first take this problem and solve it. Often it's not sufficient to solve it with a GPT-4, despite how good GPT-4o is. It's still not good enough to solve some of the grade 12 math questions. So we use a specialized math tool, Wolfram tool, to generate the steps of the solution. Once we have the steps of the solution, now we go and alter them. So we can alter the first step or the second step or, combination of steps in order to generate some incorrect sequence. And then we evaluate, we go through that incorrect sequence to generate the distractors. So the key will be the correct answer when we execute the correct steps, and distractors are the incorrect answer we get when we go through a fault. And this is all automatically done from the question. And this is, for example, how we can generate now more than just distractors, we can also generate feedback. So let me look with you on the right side of the slide, and then we'll talk about how this is done. So this is, again, the same question we saw earlier, where a student had to pick the correct behavior of this polynomial function as x goes to plus or minus infinity. And let's say they picked this. The third choice, which was a distractor, which is not the correct answer. So what's interesting is not only we want to tell the student, oh, no, this is wrong. What a good tutoring system would do, what a good feedback system would do, is would give them sort of targeted feedback. So for example, here, we don't, it's not sufficient to say غير صحيح. It's not sufficient to tell them you're wrong. We want to tell them what went wrong in the hope that the next question they'll get it correctly. So here, if you read this, and this is, as Dr. Najla sort of prefaced this by saying, this is generated with the Alam Arabic language model that Sadaya has built. So we give the sort of incorrect sequence of steps to Alam, and it can generate, and based on what the student answered, can generate this text. So it tells the student, well, you computed the upper bound incorrectly because this is a cubic function, and of course you should use only the leading term. This is the cubic term and not the linear term, which has a negative sign when you're computing the limit behavior. So actually a student can read this and hopefully they'll understand it, and hopefully when the next question is synthesized and presented to them, they will be able, it will have the same distractor, the same logic of a distractor, and we will verify whether they have been able to actually understand that that knowledge component, that fine, that granular competency that we would like them to know. So this red box, again, is synthesized automatically by Alam and generated. So we're very happy that the students, in the system, the students can get the specific feedback on what they might have gotten wrong. And again, the way we do this, I think it sort of, if you sort of heard what I said earlier, since we introduced the fault in the logic, we know where the student went wrong. So we make the assumption that if they picked one distractor, that means they went through that particular series of steps, which had one incorrect step in it, and then we can tell them this is the step that is wrong, and you can, and they need to do that. This is the system. I perhaps should not say too much about it, but sort of this is how, this is the correct series of steps, and then we can modify them by introducing a fault, and then we go through the steps of the modification to generate both the feedback and the distractors. If some of you may not read Arabic in the audience, I'm not sure. So this system also works in English as well. In that case, this is not Alam that's generating the feedback, but an English language model. This actually is an older version of the GPT. So these are very simple questions. Can you evaluate a function? And again, this is not grade 12, this is lower grades, but if they did, if they missed a sign or they missed the order of the operations and things like that, This is a bit more complicated, the question on the right. This is actually required the Mathematica, the Wolfram, to actually generate the solution. These are these gigantic numbers. If one were to try to solve this naively, one will not get anywhere. We'll get these gigantic numbers, things raised to the 18th power. One actually needs to figure out there are 4 of these things, and 16 is 4 squared, and work with that. So if one doesn't do that, if the student picks, let's say, this number, then we can tell them where they went wrong in sort of factoring things and adding them up. So this idea that not only we generate the distractors, these are the incorrect answers automatically by generating an incorrect sequence of steps and following them, but also to generate feedback to the student when they choose the wrong distractor. So we give them feedback in context when they're solving the problem. So that's the second big idea I want to introduce. The third big idea I want to introduce, and this is the one actually we really are delighted with, this is the personalized tutoring. So again, I'm still using the same example so that we have this continuity. So suppose the student is trying to solve the same question. They want to find the limit behavior of this polynomial function as x goes to plus or minus infinity. And suppose the student, needs help with this. So of course, they could pick the wrong thing and get the feedback. But suppose the student really would like to get the help of somebody, an AI tutor, what Dr. Najda mentioned in her presentation. An AI tutor is always available, always with us, available at the click of a button. So this is a conversation, again, generated by Alam, where the student would click here on the lower left button, and the student says, how can I help you? And then look, if you read this, sort of the tutor does not give the answer. The goal of the tutor is never to give answer. This is sort of a guardrail we put in place. The goal of the tutor is to guide the student in what could be the next step in figuring out the solution to that problem. So the tutor knows the context of the problem that the student is working on, and it says that you start here by saying, look at this function. This is a cubic function, and that takaibiya. Do you know what a cubic function is? Then the student types, how can I check? Well, and then the tutor says, well, okay, then this is how you would check if something is cubic. And then let's move to the next step. Okay, and the student said, yes, I can go to the next step. And then the tutor says, well, the next step is to look at the leading term of this function, and so on and so forth. So the idea is to have a conversational tutoring system, not a tutor that gives an answer, not a tutor bot that just tells the student, that's what you did wrong. It's the conversation. Through the conversation is where sort of some insights could be given to the student. And there's actually a wealth of data that can then be mined, perhaps, even though currently we're not mining it. This is just we're generating. And the fact that we have sort of a reasonably sophisticated large language model in Arabic, the Allam model, allows us to actually do this comfortably and speak with it. And so we're very happy with this. Now, the last idea I want to introduce, actually, this is just another example. I thought we'll see some more. This is also another part of, typical grade 12 curriculum type of thing. Does one know the difference between the natural numbers and the whole integers, positive and negative? And if someone doesn't know, we can give them feedback, but we can also have a tutoring conversation to tell them the natural numbers are the numbers that are, positive integers, et cetera, et cetera. So these distinctions are kind of subtle. And it's not enough to just sort of mention them. It's nice to have this sort of conversational style where step by step, a student is sort of led to an answer. People in the literature have invoked Socrates. This is sort of the Socratic way of learning and of teaching. Is this sort of where the student converses, and then we do this in a rather personalized way, because it is in response to what the student asks. And then once we're done with that, we would like to see what the student knows. And as I said, if we hang everything from the outer ring of this model that you see, the outer ring are the individual sort of knowledge components that we assessed. So you see sort of green, the student gets that concept, the red, the student doesn't get it. And then there are, of course, shades in between. So this fine-grained model, it's quite nuanced. And this is what allows us to monitor what the student knows, really identify where they're weak in, and perhaps, suggest where they would need more questions and more help. And these right now, this is data that sits in a database that can be mined, but also this is a particular student. This is the concept they're working on, the big concept they're working on. These are the individual sub-concepts they need to understand, like, limits, like inverse functions, like, I don't know, composition of functions, tarkib dalatain, et cetera, et cetera. So these are the kinds of things. And each one is associated with a bunch of individual knowledge components from which everything hangs. And this is, of course, consistent with the Saudi curriculum. So that was our starting point. We took the textbooks, extracted the knowledge from them, and used them in our tutoring system in this. And of course, these are available, so a teacher or even a student or a parent can browse through them. So we see these spider webs, if you click here. So on this topic, this analysis of functions that one typically in a typical classroom would spend maybe a month on in a typical academic year, these are the individual concepts, and this is sort of how well the students understand them at this current point. And one can go down further for a particular concept here. For example, these inverse functions and inverse relations, al-alaqat wad-dawal aksiya, how do they how the students fare in the individual knowledge components that make up this particular concept of the analysis of functions topic. So one can go down this road. And of course, this data is all stored. And as Dr. Najla said in her presentation, this is a rich source of data analytics. So students can ask about their performance. Teachers can ask about performance. We can generate graphs and plots and maybe give insights on where things can go wrong. So my final thought, I am very, very excited about the sort of revolution that we're seeing with AI-assisted education. I mean, really, sort of what large language models have given us and what the ability of them to sort of reason and give us reasoning steps, and with advances in general machine learnings for querying large data and getting patterns in data, really can allow us to build AI agents that are available anytime, anywhere, and that can be personalized to the needs of students based on the student model, based on what they know, where they are, what are the individual knowledge components that they have done. However, I do want to sort of put a little note of caution here. I've been long enough in this business to know that it's a far-fetched dream to say we're going to just put a tutor bot in front of students and hope it will work. I mean, this is a whole ecosystem. This is, we need parents, we need teachers, we need advisors, we need schools to really sort of start augmenting what is currently done with these AI tutoring systems. I think if these remain individual tools in an island, they're unlikely to make a lot of impact on qualitatively improving education. We really do need to think about a holistic approach where these tools are one of many tools that are available for additional engagements between the students and their teachers and parents. We do want that thing, and this is not a trivial endeavor by any means, but it is something I should say. And then the second note of caution I'd like to say is sort of the current large language models are still inadequate right now. They don't have enough explanation and accountability, if you will, to convince people. So there is this interpretability sort of gap right now, which we're working on in the research world, but that still sort of limits the adoption. I think there are ways around it, and I think in the years to come, this will be overcome, where the language models do provide accountability and the basis for what they're doing. But sort of this is an area in very active development, and I think we really expect to see huge changes in this field in the next few years. But of course, there are many additional things I did not talk about because our current systems do not handle them. Things like speech, things like effective learning for emotional engagement with the students. These are also topics that are being worked on in the research world. And they could be added, of course, and they could augment this sort of more text-based conversation style. That is more comfortable to students and then can be deployed today in schools and other areas. And so I want to thank the Sarai Kaust AI Research Center that has funded this work, Dr. Najla, who has been a source of inspiration for us throughout this journey, including, sort of the right content to put in and how, what are the important things and what are the less important things that we should handle and we should work on in the system. The students, I mean, I cannot thank them enough. These are the people who do the real work. Those of you who are involved in research, we're sort of without the graduate students who actually do the stuff, we cannot get a whole lot of ahead here in the kingdom. So Harith Abu Shreira, Rima Zahrani, and Sultan Al-Rashid have been very, very instrumental. They are the ones who developed a lot of, this technology. And this is all embedded in an online learning management system that hosts all this stuff, and that we can deploy it, broadly on AWS. And there is a company, LifeTech, that we work with. So thank you very much.
Thank you so much, Professor George, in enlightening us on such important topics that will reshape the future of education, such as tutoring feedback, personalized tutoring, and given personalized learning assessment. Professor George, my question to you is, like, when dealing with this kind of AI applications in the classroom, how can we ensure that the emotional and effective dimension of learning, such as student emotional well-being and engagement, are actually addressed and supported and not being missed in the whole learning and teaching aspect, taking into account that those kind of AI applications are mostly cognitive based learning?
Yeah. This is a wonderful question. Thank you for the question. So you're right. Currently, our system is more text-based. So we don't ask people to turn on, for example, their microphones or their cameras. So they can just hop on a web browser, and we have of course a profile of what they're doing, and then we ask them questions, and they can call on the tutor, and if they answer incorrectly, they get feedback and then all that stuff. However, it is possible to start acquiring more information from the student, not just the cognitive thing, not just sort of what answers they picked from the multiple choice or what questions they asked of the tutor. We can start asking them to turn their microphone on, perhaps, and either start verbalizing the question and take, their tone of voice, whether it's a questioning tone of voice or whether it's a confident tone of voice. And these can be identified, and these also can be used in how the tutor responds to the student. So rather than just taking the words, if the words are said in a very tentative way, then the tutor probably wants to reinforce the concept and repeat it again and ask a simple question. And if the student answers confidently and quickly, and then the tutor can sort of move on. So these kinds of cues in the confidence, for example, of the answer can be obtained from voice. The camera adds a whole new dimension. So if we ask the student to turn their cameras on, and then we can look at their facial features, it's probably not too difficult to think about, and there is a lot of good work, good research going on right now, to sort of, based on how the student is looking at the question, whether they're startled or whether they're confident, or how their eyes move, we can sort of whether they're scared of a question. Again, the tutor can adapt their conversation and modulate it to fit that the emotional context of the student. So these are additional, of course, areas that we need to work on. Right now, we are still we're developing the system that does not ask the students to turn their cameras and microphones on, so just a web browser, partly because of ease of deployment. I mean, this system, can be deployed quickly. When we add the additional complexities of video and sound analysis, there is a bit more work to do, but I think in the years to come, we certainly expect these additional things to happen. I mean, we do want these tutors eventually to closely resemble human tutors.
Yeah, of course, definitely agree. Thank you so much, Professor George, and to shed some light on the possibility of leveraging AI to act as a peer learner. Please join me in welcoming Engineer Mohammed Janani, the Instructional Design and AI Integration Manager at IATC. Please, Engineer Mohammed, led some light on this topic.
Okay, first of all, thank you very much to all the guests, Dr. George, Dr. Najla, for sharing your insights. It's really useful for me to hear from experts in the field, because I probably come more from a instructional design, more kind of like I was, okay, a bit about myself, I was a teacher starting off. So I bring a lot of the teaching application into instructional design. And I've been working with IATC, we're working in the aviation sector, aviation training. And so we have been experimenting. Instructional design is basically when you use whatever tools are available to you to enhance learning and deliver your learning outcomes. So with AI, it's just an extension of, in the past, it used to be like PowerPoint, it used to be articulate storyline and so forth. And those are still tools for training. But with AI, there's many ways to enhance that. And I'll just go through some examples today. There's a lot, but I won't go through everything. I'll try not to. If I can start with just one of the things I want to talk about today is going to be AI conversations. But before I get there, the conversation is actually hosted within our human factors training course. So human factors is a regulatory training. I know I'm just cautious that some of the audience might not be familiar with aviation training. So human factors is training around the factors that affect performance and affect safety and the errors that might be involved. So within this course, before I go to the conversation parts, you can see immediately the homepage itself is contextualized to Saudi Arabia and to our learners. The curriculum is from GACA, which is the Civilian Aviation Authority in Saudi Arabia. But the images, all of them, in fact, everything you see in the course, anything I show you actually is all AI generated. And so all of these images are AI generated, and they reflect our audience, they reflect our learners, from the uniform down to, of course, then they look like Middle Eastern Saudis, and we also have female staff, female learners in here as well. And what that does, it allows us to contextualize with the whole culturally responsive learning. It allows us to contextualize the learning environment to students, so they actually see themselves in the actual training. Now, I won't go through the entire course. There's a lot in here. What I want to focus on is in particular down over here. Now, the course, the way it works is it goes through some of the theory about human factors that affect performance and safety and so forth. It goes through human error. It talks about the dirty dozen, which are, again, things like complacency, things like fatigue, different factors that disrupt performance. And at the end of it all, there is a case study. So in this case study, we have again, contextualized Saudi Arabia. We've got this situation where Saudi Airlines flight, and the aircraft was just parked, and I'll just quickly press play. Nothing really happens much. It's a very short video, 15 seconds, but just from this itself. So as you can see, the the ground worker, he was blown off his feet. And this is an example of an incident, an error that we can learn from. Now, I'll come from a teaching background, and if I was showing this to students in a classroom, how would I turn this video into a useful activity that meets my objectives? I want the learners to reflect. So what would I do? I would probably ask them questions and say, look, get into pairs, get into groups, and discuss, what went wrong, what did he do, what could he have done, what were some factors involved from the previous learning you've done, what kind of human factors might have contributed to this, etc., etc. So that's what I would have done in a classroom. What about if there was no classroom? And currently, universities for the last many years have had self-study courses. So this entire course is a self-study course. I should have clarified that. There is no instructor involved here. So traditionally, in self-study university courses, what do instructor designers do or trainers do? They have a discussion board, and you go to a discussion board and you talk about something with other humans. And if someone responds to you, that's great. And if, a lot of the time, no one responds to you. And if they do, it's maybe not as valuable as what I think this activity is. So after watching this video, learners are encouraged to click on this button. And I hope the sound is working. I did turn it on. If not, just let me know, Dr. Alat. Just let it load.
Hi, I'm Dan. May I ask your name?
Hi, Dan. Yeah, my name is Janani.
Hi, Janani. Nice to meet you. So what did you think about the video? Pretty interesting, right?
It was interesting indeed. I think the ground worker, he was a very lucky man. He didn't walk in front. He was walking behind. But even then, yeah, I think he made a major error there.
Yeah, Janani, he was definitely lucky. Walking behind a running engine is dangerous enough, never mind in front of it. What do you think might have caused him to make such a risky mistake? Any human factors come to mind?
It's hard to tell because there could be a lot of human factors involved. But from me watching him, I saw that he might have looked a bit distracted, like his mind was on something else. That's what I think. What do you think?
I think you're onto something there, Giannani. Distraction is a big factor. It's possible that he was mentally occupied with something else and wasn't fully aware of his surroundings. Maybe he was thinking about his next task or something going on personally. Do you think there might be other human factors at play here too? Like maybe the environment or the resources he had?
In terms of environment, I mean, he was walking past the aircraft, and there was nothing to alert him to the the hazard. So I guess the environment could have helped him a bit more. There could have been something to alert him. I'm not too sure what, but yeah, I think there could have been something to alert him.
Yeah, absolutely. The environment plays a big role too. There could have been better signage or physical barriers to keep him away from the hazardous area. Maybe even some visual or audible alerts when the engine is running. What do you think about the resources he might have had or needed? Like, do you think he had all the information or tools he needed to stay safe?
I like your idea about the alerts and some signage and stuff. But as for resources, I don't know if I guess you could. I know we studied about the pair model, and I know that the humans are also a resource, and he should have he should have had some. I think a partner that could have helped him. That would have been a good someone to kind of remind him. What are your thoughts?
I totally agree, Giannani. Having a partner or a buddy system can be a valuable resource to increase situational awareness and catch potential mistakes. It's part of the people aspect of the peer model. Sometimes another set of eyes can make all the difference. So if he had a colleague with him, they might have reminded him to steer clear of the area. Do you think there's anything else that could have been done to reduce the chances of this happening again?
I mean, we covered signage. I mean, if he was tired, then I guess the leadership, they should probably look at giving him some more breaks. But it's hard to tell. But breaks could have helped if fatigue was an issue. but it's hard to tell. Maybe he just needs to make sure he's taking his own breaks actively himself. I'm not too sure. Yeah, help me out here.
Yeah, fatigue could definitely be a factor. If he was tired, he might not have been as alert as he needed to be. More breaks could help, but it's also about making sure those breaks are actually taken and used effectively. It's up to leadership to create an environment that encourages taking breaks and managing fatigue. But ultimately, the worker also has to take responsibility for their own rest and well-being. What do you think about the role of communication in this scenario? Could better communication have made a difference here?
For sure, for management. But I'm just gonna pause here and ask you, Dan, because I'm getting tired. Can you give me your address so I can come over to your house and we can have a cup of tea and talk about human factors?
I understand it's been an intense discussion. Unfortunately, I can't share my personal address, but we can definitely continue our conversation here. Maybe we can take a quick break and then get right back into it? How about we wrap up with one final thought?
Okay, I'm just gonna end it there. That last question was just to stress test and see if I can break the AI into doing something silly. And fortunately, Dan didn't do anything silly. So yeah, that's an example of, to me, a very. In fact, I've done this with several aviation specialists. To disclaimer, I'm not an aviation specialist, so maybe that's why I was asking Dan for help. I'm an instructor designer who has a really talented specialist around him who help him. So when I've done this with the aviation SMEs, they've found it really valuable. I've also found it valuable because I find it actually in many ways better than a discussion board on an online forum at a university. I find that something like this allows a learner to think through their thoughts and apply. So Dan was asking questions that are from the course about the pair model, and it's a chance for us to. Traditionally, we would have some kind of an essay or some kind of a quiz, and we do have quizzes here because we're still in the innovation stage. But yeah, I feel like these conversations are definitely one of the ways forward, and this is one of our first experiments in that area. Now, I want to talk about another experiment. Now, this is a voice. I'm a big believer in the voice conversations. I work with. Obviously, I'm from the UK, so English is not an issue for me. And writing English. As for our learners, our curriculum, the industry is in English language, so it's very regulated in that regard. And our learners, the text-based AI is a bit more challenging for them. That's why we're I'm a big proponent of the voice conversations, and they've had the most. I was a big fan also of the OpenAI announcements for GPT 4.0, the new voice models. This does not use that. This is still the old models, and I want to extend that further. So this, by the way, this activity was only just a conversation. It's actually quite simple. It's just reflection. If you think of the objective, is just to get the learner to reflect and apply. There's no actual like right or wrong answer that we're quizzing the learner on. But what if we wanted to do that? We wanted to go further and actually do something a bit more demanding, a bit more heavy. So for this, this is an experiment I'm literally just working on. Actually, that's why I'm very tired. I was working on it. I thought I'd give you a shot. So this experiment is, bear with me, if I explain to you the context, bear with me. Okay, so the context is we have a course on GACA regulations. And now that's the overall, the objective from the course. Someone gives to us, it could be a client, it could be a stakeholder, it could be a regulator. And if you give the AI a topic called teach about the GACA regulations, it's gonna totally mess up. So as instructional designer, we have to first identify and clarify those goals. What does GACA regulations mean? I'm just moving on to a new activity now about GACA regulations. What do the GACA regulations, when we say learn about it, what do we mean? And in this example that I'm going to show you, I've drawn it down to to navigate, to identify the correct regulation and to navigate to it. So that is going to be the objective. Now, what's going to happen is, before this has even started, what's happened is that objective has gone to an instructional designer, an AI, and a subject matter expert, an AI. And they basically go back and forth to come up with a high quality learning activity. This, by the way, is literally stimulating what I do with my SME colleague, William, and we basically go back and forth. And this is what these two are doing. They go back and forth and they come up with a lesson plan. But the cool thing about this lesson plan is that the activity within it is personalized and contextualized to the learner. So each learner is basically going to get a personalized lesson plan, pretty much. In this scenario, it's going to be me, but it could have been anyone else. And then that lesson plan is then developed into a scenario, and then that scenario gets passed on to two AI actors, pretty much. And we're going to just have a go now. Disclaimers: I didn't do this one live because it is very fresh. It's a prototype. It's actually it's very rough around the edges, so there will be many problems, technical issues. So just bear with that. And I'll just press play. I put it on 1.2 on a faster speed because of the speed. There is a delay in the audio coming back. But yeah, so remember the goal of this activity is to apply, is to navigate the GACA regulations document. And GACA regulations, just for your awareness, it's really intense. We're talking hundreds of pages here, and it's part of the training. When you say navigate, we want learners to navigate according to their context. But let's have a go anyway. So the simulation begins with welcome to this AI simulation activity, and my ID number is provided, and that's what allows the system to pull out the activity, the lesson plan. To recall back over here, the two AI models, they already developed a lesson plan for me, and that ID number is going to allow the system to draw on that pre-prepared lesson plan and that scenario that's contextualized to me.
Hi, Janani. I'm Zaid. Great to meet you. How are you doing today?
Hi, Zaid. I'm okay, and I'm interested to hear what you've got in store for me.
Okay, so this is Zaid. He's going to be like the peer coach, mentor kind of character.
That's wonderful to hear, Janani. Today, we've got an engaging activity lined up for you. It'll be a great chance to practice navigating and applying the GACA regulations in a realistic context. You'll be receiving a phone call from a colleague, and this will be an opportunity to put your skills to the test. Do you have the GACA regulations in front of you? Let me know when you're ready to start.
Yeah, I've got the regulations in front of me, and yeah, can you tell me exactly which regulations I should have ready? Can you tell me a particular number?
Okay, so at this point, I asked for the actual number, which regulation I should be looking at. But according to my lesson plan that I don't know about, it's in the back end. The lesson plan says that for the challenge, I shouldn't know the actual. That would be giving away the navigation objective, right? If the AI tells me the lesson plan, sorry, the particular regulation to have open, then that defeats the purpose of me identifying and finding the correct the correct regulation. So this was a stress test to see whether the AI would give into my request.
Awesome. Well, I can't give you the exact numbers right now. Don't worry. You'll be guided through the scenario, and instructions will naturally come up. You're well prepared with those regs in front of you. Are you all set to get started with the activity?
Yep, I guess I'm ready. I have no more questions. Yeah, let's begin.
Yeah, so Zaid didn't give in to my request, and he knows about his limits. Now he has a bit of a glitch bug. You can just ignore it if you see any glitches or bugs as this develops.
Great to hear, Janani.
Hey, Janani.
I'll get you started with your colleague now. Good luck, and remember, I'm just a call away if you need me.
Okay, so this is the colleague. The scenario, if you recall, was that the colleague from another department within the company is going to call me. The AI knows my company. It knows I work in training, I work in maintenance, and so this call should be. Remember, the GACA docs are hundreds of pages long, and we don't want to test learners on all those pages. We want to test them on the regulations that are applicable to them. So in this case, because the AI knows that Janani works in the aviation and maintenance sector, training sector, it should ask me for maintenance-related regulations.
Hey Janani, it's Fatima. How are you doing today? We've been pretty swamped here at the hangar getting ready for the audit. You won't believe how busy it's been.
Yeah, I can imagine. Audits can be very busy. We're very busy as well ourselves. Yeah, sure. I mean, is everything okay with your preparation?
Well, that's actually why I'm calling. I'm a bit uncertain about some specific GACA regulations, especially regarding our maintenance records. We're dealing with a lot of documentation for the hydraulic system overhaul on the Boeing 777. I've tried looking it up, but I'm getting a bit lost. Can you help me navigate to the right sections and maybe read them out so I can ensure everything is correctly documented?
So you want the regs for the documentation, right? Let me think. Documentation. As far as I know, documentation you're going to find it in.
All right, at this point, just remember, I'm not an aviation expert, and normally I would have consulted my good friend William on this, but I'm going to basically blag it now. I'm going to just lie and tell the AI that all sorts of nonsense, and let's see how it does.
Part 25. Have a look at part 25.
So I'm wrong, for sure. Just made it up.
I thought it might be somewhere else. Maybe, but I'm not entirely sure. Could you double check and read out part of the regulation that talks specifically about maintenance records for me? I'd really appreciate it.
Zaid, are you there? I'm a bit.
So at this point, I am stuck. I haven't obviously studied my regulation course properly. So this activity would have been part of a course about GACA regulations, and I haven't. If I'm at this stage where I'm making up nonsense, then that means I haven't studied, and I need help from my good friend Zaid.
Maintenance records for me? I'd really appreciate it.
Zaid, are you there? I'm a bit stuck here actually.
So this is a bit of.
Hey Janani, it sounds like you're having a bit of trouble finding the right section. Have you tried looking at the index of GACA regulations? It might have a more detailed breakdown of where to find specifics regarding maintenance records. What do you see there that might help?
Honestly, I looked at the contents page and it was too much. I couldn't. There's too many documents. You gotta help me out here, man.
Okay, Janani, I've shared a job aid with you that organizes.
Okay, so this part is I'm really excited about. This was pretty much throughout this whole activity or any activity, the benchmark in education for me is what would I have done as an instructor or an educator? If someone asked me a question like this, I would have shown them pretty much what this AI model is showing. It's showing the job aid to help answer my question. So that I think is really cool. I think it is adapting to my need. It's seen that I need help navigating, and it's pulled up a resource that will help me navigate.
The gate card into broad categories. Take a look at that, and it should help you pinpoint the right sections. Once you find it, we can go back to the simulation. Let me know how it goes.
Okay. I think I'll give it a shot, although I'm not too sure. Can you pinpoint? Give me like a rough indication of where it might be. I need a few more tips because it's not. It's actually not. I need to revise this a bit better.
Sure thing, Janani. I'll give you a moment to explore the job aid with the GACA index. Look specifically for sections that relate to maintenance records and mechanic training requirements. When you feel ready, let's jump back into the scenario. Just let me know when you're good to go.
I'll have a go.
Okay, so he gave me a tip. He didn't actually tell me the answer.
Let's jump back in. I'll have a go.
Sure thing, Janani. I'll give you a moment to explore the job aid with the GACA index. Look specifically for sections that relate to maintenance records.
Yeah, Fatima, I can see that you have a look at part 43. That should have aircraft maintenance regulations.
Great, thanks Janani. I'll take a look at part 43. Could you help by reading out the section that specifically covers maintenance records? I want to make sure everything is documented correctly for the audit.
So the simulation, the activity isn't finishing until I have demonstrated those objectives that the instructional designer AI model set, which was to be able to navigate and also specify the actual text that is relevant.
I'm really sorry, I couldn't actually find. I know it's part of 43, but I couldn't actually find the particular clause you wanted. So yeah, I'm sorry about that, Fatima. I don't know where you got the impression that I'm a GACA expert, but I did my best. Sorry, I couldn't help you any further.
No worries, Janani. I appreciate you trying to help out. I know this stuff can be really tricky.
Okay, I'm going to end here. So at the end, after all of this, the simulation ends and Zaid comes back in, runs a debrief. This recording, I didn't catch it, but he runs a debrief, does feedback, and sends an email summarizing the the summary of how the interaction went, areas for improvement, and the resource, the job aid resource, and other links to the courseware that will help me. Now, the part which is the next part for me, because these are all experiments for me, currently in testing and prototypes and so forth. And the next part for me to see where can we take it next. I mean, we heard the term adaptive a lot, and it is probably one of the biggest challenges. So the part for me here would be, this is Zaid, this is the colleague. In this case, it was Fatima, but the colleague changes each time. They have done this interaction with me. They should have identified that I struggled with X, Y, Z. And then that what will happen, as would happen with a normal human educator, after any interaction, you reflect, okay, what happens next? And what this instructional designer would get the report of how the interaction went, and should then know that Jinani, he struggled with navigating and actually reading out the clause. The job aid helped him. And the next challenge would be, can the instructional designer and the SME team of AI team, can they come up with a lesson plan that is then adapting to my weakness and personalize it again and create another scenario, and I can come back and have another go. So that, I haven't made that yet. That is something that I'm still working on. It's still very rough around the edges, but the voice conversation you saw with Dan is live and it seems to be working. But this to me is the next frontier, in my view, of adaptive, simulation-based, scenario-based learning that's contextualized. So when I say contextualized, if it was someone else who's not in maintenance, if let's say they were a ground worker, the regulations that were given to them would be about ground workers. If it was cabin crew, it would be about that, and so forth. So yeah, I'll probably stop here. I'm very excited about this space. I think that education she needs to go through, or it can go through a revolution. Might be a strong word, but I wouldn't be too far off. I think a lot of these we can rethink assessments. What you just saw there with Zaid, that to me, if it gets nailed down with accuracy, to me, if you get the transcript, the recording, this is evidence of competency, maybe more accurate than an MCQ quiz. It's a multiple choice quiz that just shows someone can answer some questions. Those have worked for us for a long time. But in my view, if we can nail down these kind of simulations, these kind of activities, where there's evidence of someone actually showing that, in these various contexts, they can do this skill and they would have done this, I think that can be a form of assessment. I believe it still should be human approved and with verification from a human. But yeah, I'm keen to see what's next, basically. And I'll keep exploring, and hopefully, Dr. Fatima has obviously spoken. I think she's also keen to do some research into this area, and I'll be very keen to see if these experiments are as appealing and as impactful as I think they will be. Thank you very much. I'll stop my sharing, and I'm happy to take any questions.
Thank you, Dr. Mohammed, for demonstrating this AI study partner, and actually seeing the amount of extending of the discussion, like going from basic questions to other questions, and seeing how when applied into the educational, let's say, background, the learners can be engaged in more and reflect in more knowledge and also learn from this model interactively. So my question to you, Engineer Mohammed, with this technology right now, how accurate do you see it, and how, like, let's say if we want to apply it in our schools and benefit our learners from it today, how far away are we from this dream?
So accuracy is definitely a careful one. And if you recall, that's why in the Dan conversation, I didn't call him a tutor or a teacher. Even in his programming, he's not a tutor or a teacher, he's a peer learner. And that is important because for learners, if you tell them you're talking with a teacher, then they basically submit authority to the AI, and that's not correct. The AI has to be challenged, or the learner should be ready to challenge the AI. And I don't know if you saw the call out in the course. It says that, you know, Dan may make mistakes. He's a peer partner. Feel free to push back if he makes it. The whole point of the activity is that if he does make mistakes, use your learning from the course to push back at him. But he hasn't actually made mistakes so far. But it is in my view, to frame it as not as a tutor is important for most activities. Now, secondly, I think it's important to avoid high stakes situations, learning activities. Everything you saw there was pretty much low stakes. I'm still going to have my traditional quiz because those are airtight. You can't really get them wrong. And the activities you saw they're not really graded today. In the future, I think they might be when there's maybe human approval. But yeah, they're not graded. So I think at this stage with experiments, avoiding high stakes graded activities is a safe option. Thirdly, I would say that sometimes, like the ZAID activity you saw, the GACA regulations, that one actually is accuracy based. That one, there is actually, there are some correct regs, and there are some correct answers basically. So unlike the human factors one where you're discussing and you're debating. So for that one, the way around it is, I'm just gonna very, very briefly just share my screen to answer this question. Actually, I can't speak. Basically, the way around it is to have used a human metaphor. Me as an instructor, I'm not an aviation expert. So if someone asks me to assess or to create an aviation activity, I would get it wrong as a human because I need to work with my SME who is an expert. Now, the SME may not be an expert. He's an expert in aviation, but not expert in English. So therefore, he would probably need an English language expert before he publishes, let's say, an English language test in aviation. So what I'm saying is, just as us humans, we collaborate and we plug each other's gaps. The AI models, when you want accuracy, you have to let them plug each other's gaps, and you have to work in teams. So I was very excited to see Dr. George's multiple choice maths question because we had a similar one. It wasn't about maths, it was about aviation. 300 textbooks, we drew from them, but the way that the questions come out are a team of 4 AI models. One of them is basically me, instructional designer. The other one is my SME. He's an aviation expert. There's another one who's an English expert, and another one is a quality assurance. And all 4 of them, they pass off the activity, the question between themselves to ensure that the question is accurate from an educational perspective, which is the ID's job. It's accurate from an aviation perspective, linked to the aviation textbooks and these topics and regulations. It's accurate in terms of English, so the English expert would review that. And the quality assurance person is basically doing a quality assurance of the entire thing before it comes to a human, again, the real human, to review. So that's how some tips for ensuring accuracy. I think we have to be careful I don't think it'll ever be a situation of AI is going to go and replace a curriculum. I think he has to be carefully opted in to particular sweet spots, I call them. So the human factors discussion is a sweet spot. Discussion and debate is a sweet spot. Role play is a sweet spot because AI is just an actor. If you think of prompting, the first thing you say to an AI is "You are a XYZ." So if any learning activity that can benefit from role play, and simulations, I think that's where AI might be the strongest, and you will find the least issues when it comes to accuracy. Those are my opinions. Again, all experiments, and I could be wrong.
Thank you so much. I'd like to take a minute, allow each of our expert speakers to have a minute to wrap up and give us any final thoughts regarding adapting AI in the educational ecosystem. We're going to start with you, Dr. Najla.
Okay, thank you very much, Dr. Ala. What I'd like to end this with is that again, although we can see a lot of AI applications all around us, and there are numerous AI tools available, we need to be careful when using these tools. And the other thing that I wanted to point out is that although we're always hearing rumors about how AI will replace humans, this is not the case. AI is, at the end of the day, just a tool that which would be used to help or enhance an experience. It would never be a replacement for human beings. Thank you.
Thanks a lot, Dr. Najla. To you, Dr. George.
Thank you. So I sort of second that. Definitely, these AI systems are meant to enhance the educational experience. We hope they free time for teachers, so that teachers have more time to spend with their students. So freeing some of the drudgery they have to do in preparing multiple choice questions and in getting insights from the data, and all these kinds of things, and giving basic tutoring instructions. I was looking at the question and answer, the questions a little bit here, and there are a bunch of questions about, there are many of these AI systems. How can we use them? How can we adapt them? How can we adopt them? And I think the truth is there are many. This is a big sector. It's growing. This is really, everybody expects it to have a transformative effect on education. And I think the key here is to make sure it's customized to the curriculum you want to teach. I mean, just we saw Dr. Muhammad, he was talking about, the aviation domain. So if we're talking about, high school, math or science or whatever, it has to be customized to that curriculum. That's where most of the benefit can be obtained. If it needs to be customized to a language, as sometimes it's needed in Arabic, then it has to be customized to the kind of content that the students need, and then the language that they actually converse in and study in. Otherwise, they will not get much benefit. And eventually, this has to be integrated in the platforms that are used in the kingdom. For example, in our case of grade school mathematics, for example, Madrasati or other platforms that are available. Eventually, these tools will be available so that teachers can use them when they need them, as they need to. We're very excited about this, but yes, I think one has to always have caution in mind when using these and adapting these tools. These have to be used by teachers, and supervised by parents and educators. It's one more arsenal we have.
Thank you so much, Professor George. To you, Engineer Mohammed.
Yeah, thank you very much. I would add that despite all the advances with technology and AI, and it definitely is an advance, there's no way to deny that. During my work in these projects, I realized that one of the strongest actually asset is the human ability to reflect, evaluate, think, and assess. Because an AI, like I said, is just an actor. It's mimicking, and it's going to mimic your processes, your thoughts, your systems, your challenges. And if you can't reflect on those, you can't understand your own processes in your own company, your own work. If you can't understand your students, for example, where they're coming from, what they need, then the AI model isn't going to save you. It's not going to help you in any way. It's only going to do whatever you understand the situation to be. So I wouldn't see as an either-or situation where there's AI and humans. I would see that the AI is actually quite useless without a very intelligent, human brain that's basically guiding the system to do something. accurate. So yeah, that's probably one of the, my reflection is that I would probably encourage rather than the tools, if we start reflecting more deeply on what it is that AI systems can benefit us in, that would probably be more appropriate and more effective.
Thank you, Engineer Janani. In conclusion of our webinar, we can say that the transformation that impact us from AI in education actually are huge, and AI on education presents a promise complicity. Let's say AI is not only enhancing existing educational approaches, it is fundamental to reshape the way we approach learning in the future. In the conclusion of this webinar, I'd like to thank Dr. Najla Tuwajri for joining us today, and Professor George Tereka and Engineer محمد جناني. أود أيضا في ختام هذه الندوة شكر المركز الوطني للتعليم الإلكتروني على هذه الفرصة، وشكر جميع الضيوف الكرام على حضورهم لهذه الندوة الافتراضية. كما أأمل منكم تعبئة الاستبيان الذي ترونه ظاهر أسفل الشاشة بغرض التحسين والتطوير. سعدنا بكم ونلتقي بكم إن شاء الله في المزيد من ندوات المركز. شكرا جزيلا.